Hey guys, I'm Anubhav, the physics tutor, and today we're working on rotational motion. So take a quick second just to pause right here and read through the problem so you know what we're working with. So in this question, we're applying a force to this wheel to roll it on top of this step of height h. Since we have rotational motion being caused by a force, what concept does that remind us of? Narrowing down to a concept at the beginning of a physics question will help us narrow down which equations we're going to end up using later on. And here, if we have force causing rotational motion, we're going to be working with torque. Okay, so we're going to start with part A of this question, in which our force is being applied up here on the top surface of the wheel. And I'll leave part B for you guys to figure out on your own time. Just follow the same steps we used to get to this solution, okay? And our force applied must cause a torque large enough to roll our wheel up onto the step. And what's resisting it? What's causing, because any force applied to this wheel will make it pivot over onto the step. What's preventing it from happening? Intuitively, some of you guys might think that it's the step itself. It's kind of in the way, blocking the path of motion. But really in this case, it's just acting as a pivot for our wheel to move up to the top. If you look at it and look at a force body diagram, it's the weight of this wheel, the mass times gravity, that's going to cause this wheel to fall back down to the lower step and prevent it from moving up. Okay, so what we just figured out was that the force applied, the torque from that force, needs to be greater than the torque caused by gravity pulling our wheel back down to the lower step. And as a quick crash course recap, torque is force times the lever arm. Now, sometimes you might see this as force cross distance or force distance sine theta. Essentially, the overall concept that you need to keep in mind is that torque is maximized when force and the distance or the arm on which it's acting on are perpendicular to each other. So for quick practice on torque, let's take a look at this wrench I've drawn. Now, let's say our force is being applied in this direction in order to turn our bolt. And this is our force. And our length is always the length from the pivot point. So our length or our distance from the pivot point, which is the bolt, to where the force is being applied. And now there's two ways that we can try to determine torque. The first step is to either determine the component of the force that's perpendicular to our length, or we extend our force and determine the component of our length that's perpendicular to our force. Either way, you're doing the cross product and you'll get torque. And it just depends on which angles are provided to you. So keep an eye out for those. Now that we've caught up on torque, and we know that the force applied's torque needs to be greater than the torque due to gravity, our next step is figuring out what do these torque expressions equal. Awesome, so let's get started with calculating the expression for torque due to our force applied. In this case, we need to determine the force's magnitude and the magnitude of the lever arm, because as we just recalled, torque is equal to force times lever arm, right? Here, the pivot point, or where our wheel is pivoting over, is the step. And the distance between our force and that step can be drawn by this line right here. And we mentioned before that there's two strategies to determine torque. Either we find the vertical component of force or the vertical component of this length. Now, to find the vertical component of the force, this right here, we would need some kind of angle theta, which isn't provided to us in this question. So we're going to have to skip that strategy. Instead, we're going to try to determine how can we get this length that's perpendicular to our force. And it seems like they've provided us two different distance values. They've given us radius and height. Well, if we multiply radius by 2 to get 2r, we get the distance from our force to the ground. And by that logic, this distance should be 2r minus h. Plugging that into our torque equation, we get that torque due to force applied is force times 2r minus h. Okay, once you got that, same exact strategy here. We figured out in the very beginning that the force that's resisting the wheel from going up is gravity, and it's also providing its own torque, but in the opposite direction. So we have the mg of its wheel here, the same pivot point, and in this case, the length from the pivot point to the force applied looks like that. Again, same issue. We don't have any angles theta to get different components of our force. We would look at a component like that that's perpendicular to the distance, but no thetas, so we can't do that. What instead we're going to do is try to get this component of the length that's perpendicular to our force. Okay, so how can we do that? Let's see. Torque due to mg is equal to the force, which is mg times our length perpendicular. We've got a right triangle here, and I think we can figure out some of these distances. We want to get this one on the bottom, right? Let's look at the hypotenuse. The hypotenuse is just the radius, right? And one leg of this triangle is the radius minus the height, so r minus h. If we've got the hypotenuse and we've got one of the legs, then the other leg using Pythagorean theorem is just going to be the square root of c squared minus a squared. Plugging in our hypotenuse, which is r, and one of our legs, r minus h. Sorry for the mistake. If we've done the square root, we don't have the square, obviously. We get our final leg, L perpendicular, as the square root of these two distances squared. And that just gets plugged right into our torque expression to give us the expression for the torque due to gravity. Awesome, we made it this far. Last step. From the very beginning, we realized that in order to get the wheel onto the step, the torque that our force applies onto the wheel has to be greater than the resisting torque due to gravity. In this case, we figured out that the torque caused by our force applied is equal to force times 2 times the radius minus height, this expression. And this is greater than the expression we got from the last part, this right here. And we want to know the minimum force to get our wheel onto the step. If this is what we're looking for right here, all we're going to do is move this part of the expression over. And there you have it. Any force greater than this quantity right here will let our wheel turn over on top of the step. And with that, I want to say thank you guys for listening to my first episode. Please leave me any feedback or questions you have, either in the comments below or via email, and hope to see you guys for my next explanation.